In the previous lesson, integration by substitution is introduced. This method is a consequence of the chain rule of anti-differentiation, and it simplifies the integral expression by changing the variable. Integration by substitution is helpful in dealing with composition of functions, especially if the derivative of the inner function is a factor of the integral. However, itong method na to falls short on getting the integral of some product of functions. Take for example, the integral of x cosine x dx. If we let u be equal to cosine x, then ang du natin dyan is negative sine x dx. Ang problema, wala naman tayong sine x doon sa integrand natin. Hindi naman tayo pwedeng magdagdag ng sine x or ng sine. Kasi ang pwede lang nating idagdag is numbers but not variables. Ngayon naman, kung babalik na rin natin, let's say, yung x ang u natin. Ang du naman natin is dx. Ang problema naman dyan, may sobrang cosine x. Paano naman natin ngayon tatanggalin yung cosine x na yun? Therefore, in this kind of integrals, hindi natin pwedeng gamitin yung substitution method. Luckily, meron pa rin tayong way on how to solve such integrals. So let's think of a function that has a derivative of x cosine x, or at least yung x cosine x is part of the derivative. And that is x sine x. Diba? If we take the derivative of x sine x, that becomes f prime g plus g prime f. Okay, so that is 1 times sine x plus x cosine x. So, nandito na ngayon yung ating x cosine x. Pag nag-rearrange tayo, itong sine x na to, ililipat natin sa kabila. So, that becomes x cosine x equals the derivative of x sine x minus sine x. Now, taking the integral of everything, then we have the integral of x cosine x dx is equal to the integral of the derivative of x sine x dx minus the integral of sine x dx. Note that yung integral ng isang derivative is just the function itself. Diba? Parang magka-cancel yung dalawang yan. Therefore, this becomes now x sine x minus, ano yung integral ng sine x? That is negative cosine x. So that is minus negative cosine x plus c. Or we have x sine x plus cosine x plus c. So, meron na tayo ngayong equivalent na antiderivative for this. And yung method na ginamit natin is actually called the integration by parts. Let us now generalize that. Okay? We let f and g be differentiable at x. So, that is f times g prime of x is equal to f prime of x g of x plus g prime of x f of x. Yan lang yung product rule dun sa ating derivatives. We have g prime of x f of x is equal to fg prime of x minus f prime of x g of x. So, nilipat lang natin ito dun sa kabila. Then, i-rearrange ko lang siya para mauna yung f. So, we have f of x g prime of x is equal to f times g prime of x minus f prime of x g of x. Or taking the integral of that, so we have, okay, integral tsaka derivative, magka-cancel out. The integral now of f of x g prime of x dx becomes f times g of x minus the integral of f prime of x g of x dx. Now, if we let f of x be equal to u, and f prime of x be du, g of x be equal to v, and g prime of x be equal to dv, this now simplifies to integral of u dv equals uv minus integral of v du. And this is now the generalized formula for integration by parts. Using that generalization, let's evaluate the integral of x cosine x dx. So for our solution, we let u be equal to x, and dv be equal to cosine x dx. Since u is equal to x, this implies that du is equal to dx. And since dv is equal to cosine x dx, if we take the integral of that, then v is equal to sine x. Okay? Eto, kinuha natin yung derivative, kaya naging du. Eto naman, kinuha natin yung integral, kaya naging v. So, since meron na tayong values for u, dv, du, and v, by our generalization, the integral of u dv is equal to uv minus integral of v du. Substituting, we have the integral of x cosine x dx equals, our u is x, our v is sine x, minus the integral of sine x dx. Or that is now equal to x sine x minus the integral of sine x is negative cosine x. And then, don't forget the arbitrary constant. So, we have x sine x plus cosine x plus c. So, eto yung nakuha natin kanina sa first na illustration natin. Now, let's evaluate the integral of x ln x dx. So, for our solution, we let u be equal to ln x and dv be equal to x dx. Taking the derivative of u, we have du equals 1 over x dx. And taking the integral of dv equals v, which is 1/2 x squared. Now, using our generalization, then the integral of x ln x dx is equal to, what is our u? Ln x. Our v is 1/2 x squared, minus the integral of v, which is 1/2 x squared, times du is 1 over x dx. Or that is 1/2 x squared ln x minus 1/2 integral of x dx. Or that is now 1/2 x squared ln x minus 1/4 x squared plus c. Kasi diba yung integral nung x natin is x squared over 2 times 1/2, kaya naging 1/4 x squared. Let's evaluate the integral of e raised to x sine x dx. So we let u be equal to sine x and dv be equal to e raised to x dx. Taking the derivative of u, then we have du equals cosine x dx. And taking the integral of dv, we have v equals e raised to x. Then, by our generalization, the integral of e raised to x sine x dx is equal to sine x times e raised to x minus the integral of e raised to x cosine x dx. Observe that, etong part na to, kailangan ulit natin i-integrate by parts by letting u asterisk be equal to cosine x and dv asterisk be equal to e raised to x dx. Du asterisk now is equal to negative sine x dx and v asterisk is equal to e raised to x. Therefore, okay, palitan na natin ito ng ating integration by parts. So we have integral of e raised to x sine x dx equals, eto lang yon, sine x e raised to x minus, okay, eto naman ngayon, yung integration by parts niya is cosine x e raised to x minus the integral of e raised to x negative sine x dx. Or that is now, okay, e raised to x sine x minus e raised to x cosine x plus, okay, we have plus here, magiging plus na siya. So, since negative ito, multiply mo sa positive, negative pa rin. Kaya negative pa rin ito. Okay? Integral of e raised to x sine x dx. Observe that, etong part na to, di ba same lang doon? So, pwede nating i-move yan sa kabila by transposing. We have integral of e raised to x sine x dx plus the integral of e raised to x sine x dx. Galing dito yan ha. Equals, anong naiwan? E raised to x sine x minus e raised to x cosine x plus c. Simplifying this, we now have 2 times the integral of e raised to x sine x dx is equal to this one. E raised to x sine x minus e raised to x cosine x plus c. Then divide everything by 2. We have the integral of e raised to x sine x dx is equal to 1 half e raised to x sine x minus 1 half e raised to x cosine x plus c. So that is now the integral of e raised to x sine x dx. Ngayon ang tanong siguro ninyo, ano bang pipiliin kong u? Meron tayong guidelines on how to choose u. I choose u! At yung mauuna sa listahan, yun ang pipiliin natin na u. So it starts with L, the logarithmic function, yun yung pinakauna, then inverse trigonometric functions, then algebraic functions, then trigonometric functions, and then exponential function. Now let's evaluate the definite integral from 0 to 2 of x squared e raised to x dx. So we will choose u to be x squared kasi algebraic muna before exponential. Then dv is e raised to x dx. du now is equal to 2x dx and v is equal to e raised to x. So by our generalization, that is just equal to x squared e raised to x evaluated from 0 to 2 minus the integral from 0 to 2 of e raised to x 2x dx. Or we now have x squared e raised to x evaluated from 0 to 2 minus 2 times the integral from 0 to 2 x times e raised to x dx. So, etong part na to, again, kailangan natin siyang i-integration by parts. So, we let u asterisk be equal to x and dv asterisk be equal to e raised to x dx. So, we have du asterisk be equal to dx and v asterisk be equal to e raised to x. Therefore, the integral from 0 to 2 of x squared e raised to x dx is equal to, eto lang yun, di naman yan mag-change, x squared e raised to x evaluated from 0 to 2 minus 2 times yung integration by parts nito, we have x times e raised to x from 0 to 2 minus the integral from 0 to 2 of e raised to x dx. Or we now have x squared e raised to x evaluated from 0 to 2. Okay, pinasok na natin yung 2 sa loob, dyan and then dyan, minus 2x e raised to x evaluated from 0 to 2 plus 2 times the integral from 0 to 2 of e raised to x dx. Then we now have x squared e raised to x minus 2x e raised to x plus 2 e raised to x. All evaluated from 0 to 2. So since iisa naman yung ating upper and lower limits, pwede na natin silang pagsamahin. So we have x squared e raised to x minus 2x e raised to x plus 2 e raised to x, all evaluated from 0 to 2. Or that is 2 squared times e raised to 2 minus 2 times 2 e raised to 2 plus 2 e raised to 2 minus yung sa 0 naman, 0 squared e raised to 0 minus 2 times 0 e raised to 0 plus 2 times e raised to 0. So itong mga to magsi-0 na yan. Ito hindi, yung last na term, kasi nga, that is 2 times e raised to 0 is equal to 1, kaya 2 yan. Itong part na to, magka-cancel to, diba? That is 4 e raised to 2. So we now have 2 times e raised to 2 minus 2.